Back to math. I make this video just to refresh your memory on some of the main concepts of the topics we've covered. Please look at that resource sheet. There's a quick visual for you if you forget how to do something. When you take that cumulative review, it's important that you do your best. I don't expect anyone to be getting a perfect score on that because it's a lot of information, but I just want you to do your best so I can see a good picture of what you know. The first thing I want to review with you is estimation. There are 3 strategies when estimating that I want to cover. A magnitude estimate is when you're rounding to the highest place value of a number. So 622, we'd round to 600, and we'd round that 45 to the nearest 10, which would be 50. And that would give me the basic fact of 6 times 5, and I'd add 3 zeros. If there's decimals, we want to round to the nearest whole number, which is your ones place. And when I round to the nearest whole number, I look at 35 and make it 36, and 5, and 20. 36 plus 5 is 41, plus 20 is 61. Now you may say, could I make a magnitude estimate when you're doing decimals? Of course you can, because a magnitude estimate for this number would just be making this 40 plus 5 plus 20. And guess what? My answer would be 65. So it would be very close to the other estimate I had. Another good strategy for estimating is making friendly facts. So in division, I start with the divisor and I'd round that with a magnitude estimate. And then instead of just rounding this maybe to 700, I'd look for a math fact of 9 that might make that easier to work. And sure enough, I see 720. 720 is like 72 divided by 9. 720 divided by 90 gives me an estimate of 8. When you're asked to evaluate or find the value of an expression, if there's more than one operation, you want to do that first. You want to follow the order of operations first, which is your parentheses. Adding decimals. To add decimals, you simply write the numbers lined up by their place value. When there's decimal points, it's very easy to do. I like you to add a 0 here at the end to make the place value parts even, that they're the same. I have a tenths number and a hundredths number in both. And then I simply add. And now I have the solution of the parentheses. I'm going to go ahead and multiply. Do you remember how to multiply a decimal? Well, when you multiply a decimal, you're going to multiply as if that decimal is not even there. And you're going to get this answer. Now, I have 1,581, which is not reasonable. The estimate tells me my answer should be closer to 5 times 3, or 15. The ruling is that I count the number of places to the right of the decimal point in my problem. There are 2 numbers that are to the right of the decimal. There's nothing here. So I have 2 numbers to the right of the decimal point. I need 2 numbers to the right of my decimal point in my product. You just count the decimal places. So how many decimal places will this problem have? You got it. It's going to have 3 because there are 2 numbers in the first factor and 2 numbers in the second number, and 1 number, for a total of 3. If you're dividing numbers, we want to set up our problem inside the bracket. At a school, there are 294 students going on a field trip. They are going to be put into groups of 14 students each. So you're going to be separating them into groups of 14. First thing I'm going to look at is lining up your digits in your quotient. Okay, so 14 cannot go into 2, but it can go into 29. So my first digit of my quotient is going to start right above the tens place. 29, subtract the 28, which is what 14 times 2 is. I get 1. 1 is less than 14, so I can bring my 4 down. Well, sure enough, 14 goes into 14 exactly once. I'm sorry about that. Oops, I'm going to have to go back here. It does this to me all the time, and let me go back to the view here. And I'm sorry about that. And it was 294 being divided by 14. Lots of fun. This is like my 4th video take on this, so I'm going with it, kiddos. 294, we were dividing it by 14. We had the 2, we had the 28, and I have 1 time, which gave me a remainder of 0. If there were another instance which we had to interpret the remainder, then we would look at it and think, okay, do I need to round my answer up? Do I need to ignore my remainder? But there was not one here. If you are dividing a decimal, you place the decimal in the quotient directly above the dividend. So if I had a number, say like let's call it 37 and 17 hundredths, and I want to divide it by 9. The first thing you're going to do is place that decimal right up where your quotient goes, and now you're done. You can ignore that there was even a decimal down there. Pretend like it didn't even exist. So 9 cannot go into 3, but it goes into 37 4 times. That's where I'm getting 36. 4 times 9, and I subtract. I have a difference of 1, which is less than 9, so I'm ready to bring down this number. Now 9 does go into 11, but if it didn't, you'd have to place a 0 up before you can bring another number down here. But 9 goes into 11, and it goes into 11 just once, and that gives me a difference of 2. And now I can bring that 7 down. 9 goes into 27 3 times exactly. I have no remainder. I'm done. If you had a problem that had a remainder and it was a decimal problem, let's say I was dividing this. 4 goes into 22 5 times. And that's 2. I'm going to annex that 0 right after the decimal point. We can add zeros as long as we need if that helps us do away with a remainder. We call that annexing a 0. Please remember that each value is 10 times the value of the digit to the right. So if I have 88.8, the 8 here is in the tens place. That is 80. That is 10 times the value of the 8 here in my ones place, which is 8. And then that is 8 is 10 times the value of the digit in my tens place, 8 tenths. Every place value is 10 times the value of the digit to the right. So you try this question. Thinking of place value and the values of numbers, what 2 decimals would you choose to make this true? Well, since it has a 4 in the tens place, I would choose anything that had less than a 4 because they're telling me this number is greater. So that's why those are your 2 correct answers. There's a 3 in the tens place and a 2. Please know that there are differences between word form and number form. If Isaiah is thinking about a number, 9.52 in his head, which one of these would equal 9.52? 9 and 52 tenths. No, that is 52 hundredths. So that's not right. 9 plus 5 tenths plus 2 hundredths. Yep, that works. 9 ones plus 5 tenths plus 2 hundredths. that works. 9 times 1, 5 times 10, 1/10, and 2 times 1/100. Oops, I made that one disappear a little bit. 952 tenths, that is not correct anyway, so I'm glad I covered it. But 952 hundredths, that would also be correct. So we could see numbers written different ways. This is, again, my review of the place value being 10 times the digit to the right of it. But remember now, also, each digit is 1/10 of the value to the digit to the left. So a number in a place value every time increases by 10. But let's look at my 5s. So the 5s in the tenths place is 1/10 of this, but it's an 8. So 5 isn't 1/10 of 8. It'd only be 1/10 if it was a 5 there. But the place value itself is different. But the 5 here compared to the 5 in the tens place, this is 1/100th of the value. Or 5 or 50 tens is 100 times the value of 5 tenths. All right, oops, I can't erase it now. And there's my, okay, that's it. How many times greater is the value of the 4 in 547 than the value of the 4 in 84? Well, this is 4 tens, that's 4 ones. So, I mean, they're both 4 tens. They're the same. I'm sorry, it hurts that I'm having all that. So, there's 4s both. Oh, that is the ones place. My writing all over my scribbles. Yeah, this is 40 tens here. This is 40 tens, and that's 4 ones. So it is 10 times the value. I was right the first time. All right. What is 1/10 of 4? You're dividing by 10, so you're going to move your decimal one time. B is brilliant. B is brilliant. Which expression would be equivalent to 10 to the 4th power? You're ready to go. C it is. C, senor and senoritas. Adding and subtracting fractions. Remember, you're going to need a common denominator. I have 2 good visual charts on the resource sheet that you should look at. The sum of the fractions represented, well, this is 1. This is 1. This is 1. This is 1/4. And that is 3/8. 3/8. So I cannot add fourths and eighths together until I get a common denominator. So fourths and eighths, the common denominator is eighths. So let's change 1/4 to be 2/8. Now I could add this. 1 plus 1 plus 1 is 3. And 2/8 plus 3/8 would be 5/8. If Kim's cookie recipe requires 3/4 of a cup of brown sugar, Kim has 1/2 cup, how much more is she going to need? Well, this is a subtraction problem. 3/4 and she has 1/2. So I need a common denominator again. 3/4 will stay that. I'm going to use 4 here. 1/2 is 2/4. So 3/4 minus 2/4 is 1/4 of a cup. When you're adding and subtracting fractions, please look at your 2 denominators and make a common denominator. I like to write them going vertically so you can make your problems easier to solve. 4 times 5, 3 times 5. 5 times 4, 1 times 4. And you add them. Numerators only, denominator stays the same. If I'm subtracting, I can find a quick common denominator simply by multiplying the 2 denominators with each other. When I do that, I can set up my equal fractions. 8 times 3, 7 times 3. 3 times 8, 2 times 8. Subtract, I get 5/24. Common denominators are key. As opposed to when you're doing mixed numbers, you want to set it up with a common denominator. You don't want to do anything too fancy here. You're just simply going to write your fractions next to each other, just as I did. Leave your whole numbers alone. 3 times 5, 1 times 5. 5 times 3, 2 times 3. Get 11/15, and now I add my whole numbers. Done. If you're subtracting fractions, here's a kicker one. Remember, we need, again, a common denominator, but sometimes when we set this up, and I'm going to use 9. 3 times 3 is 9. 2 times 3 is 6. I can't subtract. 2 minus 6 cannot be done. So I'm going to come back to my whole number, which is why we save those for the last. I'm going to think of 3 and 9/9 as 4, right? Because that is 9/9 is 1. So I'm going to add those 9/9 to the 2 9s I have already. That's going to give me a total of 11/9, and now I can subtract. And now I have 3. Oh, shoot. 3 minus that 1 left me with 2. All right, we're going to multiplying. The fraction of a number when you're multiplying is the same as multiplying. Numerator times numerator, denominator times denominator. If you multiply by a fraction less than 1, it will give you a smaller product. So 3/4 is being multiplied all 3 times. If I'm multiplying it by 1/3, that's less than 1. My answer is going to be smaller than 3/4. 3/4 times 3/3, 3/3 is 1. It's going to be equal to 3/4. And then if I took 3/4 times 5/3, 5/3 is greater than 1, my product will be greater than 1. So we call that a scaling factor there. If you're multiplying by a fraction less than 1, your first number is going to get smaller. All right, fraction of a number. Franklin has 24 gumballs. They are red, blue, and green. 3/8 of the gumballs are red. Well, you could do this mentally, figure out what 1/8 is, and multiply it by 3. Or you could do 3/8 times 24. And when you multiply 3/8 times 24, you would get numerator times numerator, denominator times denominator, 72/8, which is 9. So 9 gumballs are red. And if 5/12 of them, 5/12 of 24 are blue, you set it up like that. Now we did do a little bit of that reducing first. Remember, I could find a common factor. 5/12, 12 and 24 could reduce. I could divide each of them by 12. So then my problem becomes 5 times 2 is 10 over 1. There are 10 blue gumballs. So the question is, how many are green? Well, if 9 are red, 10 are blue, then green must be 5. Right? I just wanted to make sure they equaled 24. The last thing I want to cover with you is multiplying a mixed number. And to do that, you are going to want to turn them to improper fractions. So take 2 and 4/5, and we are going to rewrite them. 2 and 4/5 rewrites by taking 2 times 5 is 10 plus the numerator of 4. This becomes 14/5. And 3 and 1/2 becomes 3 times 2 is 6 plus 1. It becomes 7/2. So now I can multiply 14 over 5 times 7 over 2. Do you see anything you could simplify here? Well, 5 and 7 are both prime. I'm going to go ahead and simplify my 2 and 14 because I can divide each one of them by 2. So my problem becomes 7 times 7, 49, and 5 times 1 is 5. 49 fifths, it simplifies to be 9 and 4 fifths. And 9 and 4 fifths, let's check if that's reasonable. This is really close to being 3, and this is a little more than 3. Well, 3 times 3 is 9, so my answer being 4 and 9 fifths makes a lot of sense. All right, kiddos, that's really it. That should get you set up to do the cumulative review, use the resources,